that first blank we're filling in is the word relation. A relation is any two numbers that are related to each other. Simple enough, right? Okay, next blank. A function is a special type of relationship in which each input has exactly one output. So if we think in terms of input, output, what we talked about yesterday with domain and range, that means for each x I plug in, there's only one y value it could give me. Because I can plug in that x, work it out, and it's going to give me y. So for each input, there's only one output. And that is the definition of a function. Okay, so the different types of representations you're going to see. First, a graph, and how we determine it from a graph. It says an important mathematical skill is to be able to identify a relationship as a function or not. For graphs, we use what is called the vertical line test. And that is, if you draw a vertical line, it will pass through the graph only one time if it is a function. And I like to use a paper clip for this. So in other words, if I were to take something that was a vertical straight line and put it on top of the graph, if it crosses it more than once, that is not a function. So that vertical line will cross there and there, right? So that is a no, that is not a function. It can only cross once and be a function. So any shape, like you saw a circle, a triangle, square on a graph, that's never going to be a function because it'll always cross more than once. If you look at this next one, if I drag a vertical line over that, at no point does it ever touch the vertical line more than once. So that is a function. And then if you look at the third one, if I have a vertical line right there, it touches how many times actually? 1, 2, 3. Yeah, so definitely more than once. So that is a no. Here you go. Okay, so using the vertical line test, something else you can tell. If you look at it, you can tell real quick if it's going to pass the vertical line test. Anything that is concave horizontally, you know what concave means? Like dented in. Anything that is dented in horizontally, like sideways, that's not going to be a function because it'll never pass the vertical line test. Okay, if it's concave vertically, like it's dented in up and down, that will, because it'll only cross it once. So as long as you don't have any concave dents in the sides and horizontally like that, it should be a function. Okay, so that's how we determine it from a graph. Next, we're going to look at functions as tables. So as it says, not all relationships will be displayed as a graph. Sometimes it will be a table. Tables still have a very simple test to decide if it's a function or not. And it's, does the x repeat? Because remember, we can only have one input for every output. So all you have to do with the table is go down the x column and see if anything repeats. Here it does. You got 7s there, correct? So that is not a function. It cannot repeat. Because then we're getting two different outputs for the same input. If you look at the next one, our x's are 4, 9, 8, 0, negative 6. None of those are the same. That's what we want. So that is a yes. And then the third one, we got 8, 2, 8. So already something repeating, right? So that means that is a no. So you're looking to see if anything repeats in the x column. Because you can only have one input for each output. Yes. There's only one time you look at the y column, it's going to be a special case that I'll show you next. Alright, so if you look at the top right, there's one special case when the x's can repeat. That's if the y also repeats, because then it's the exact same point. Because if you look at this example, we got 3 2s in the x column, but what's the y on all of them? It's all the same point, right? Okay, so really you're not having a repeating x. It's the same point listed multiple times. So in that case, Yes, that is still a function. If you looked at all the other ones we looked at the bottom of the previous page, for those x's that repeated, the y's were different. They weren't the same point. So if it's the same point, it's okay. That can repeat. Okay, next, order pairs. Good news is, if you can handle tables, you can handle order pairs because it's the exact same thing. So the check for order pairs is the same as the check for tables because you can always take order pairs and write them in a table, right? Okay, so all you have to do is go down the x column, see if anything repeats. So I'm going to start with this middle one. 3, 6, 8, negative 3, 0. None of those repeat. So yes, that is a function. If I go to the third one, 8, negative 6, negative 6, negative 6. A lot of repeating. All the y's are different. That's not going to work. So that is a no. And the first example was showing you is that any table can be written over and is the same as an ordered pair. You can always take a table and write it as ordered pairs. 2, 1, 7, 3, 4, 2, 7, 1. So that's why the check for the 2 is the exact same. You're just looking at the x's. And if we go down these, we got a 7, 3, and we got a 7, 1. So would that be a function? No. Okay, that special case with tables is also true with ordered pairs because they're really the same. So if the x's repeat, like this shows you down here, but the y's are also the same, meaning it's the same point, that's okay. That is still a function. Okay, every single year, literally every year that I've ever seen the STAAR test, which is every year, they have 2 questions on the STAAR test. They're very easy if you just remember that the x's can't repeat. Okay? If you forget that, you get completely lost on the question because you just can't remember how to decide a function. They'll give you a bunch of ordered pairs and say, is it a function? So all you got to do is just look at the x's and see if they repeat. 2, every single year they do that. Okay, we're good so far there? All right, next. Next is a map. So the last common representation of relations called mapping. With mapping, each arrow indicates whether a relationship is between numbers or an ordered pair. Once again, we're checking for repeating inputs. And the way you check that in a map is you look for 2 or more arrows from a single input, so from a single x. Because if we got 2 arrows going from the same x, that means we got repeating x's. So that would not be a function. So if we go through this map, is there any of the x's that have 2 arrows starting from it? Yeah, right there. Because that means we have a point that's 5, 9, and then we also have a point that's 5, 27. So that would not work. That would be a no. What about this one? Any of them have 2 arrows? Sorry, let me be more specific. 2 arrows from an x value. No, it's okay to be going to the same y value. They could have all the same y. We just can't have repeating x's. So this is a yes. And then your last one there. Yeah, I think some of y'all are answering the final question. No, it is not a function because there are 2 arrows from the 11. Agree with that? Okay. You'll see this sometimes with maps also. See how there's a number there, 15, and there's no arrow coming from it? It's just thrown in there and it's meaningless. It's not even part of your domain. Okay? If you see a number in a map that doesn't have an arrow coming from it or to it, you can cross it off. It might as well not even be there. All right, any questions there? All right, so what we're going to do is we're going to go through each row of this. We're going to do one together, and the rest is going to become your homework. So number 1, with a map, with a graph, would that pass the vertical line test? Is there a part where a vertical line would ever cross it more than once? No. So that is a function. So that's what you're doing with a graph. If we go down to 4, any x's repeat?
No. Wait, yes.
Yeah, there are. 0, -1, 0, 3. So that is not a function. So that's a no. So this whole first 1 through 9, all you're doing is saying yes or no. If you go down to 7, yeah, it's actually got double repeaters, right? You got -1s, and then we also have the zeros, right? 0, -3, 0, -7. So that's definitely a no. Let's do one of the maps, because there's only 2 maps here. Let's look at 9. Is there more than one arrow from any of the x's? Yeah. There's no arrows from twice from any x, so yes, that is the function. Like I said, when you say no, some of y'all said yes, I think you were answering the finished question, because there are not 2 arrows from more than one x. Good there? Okay, so that section won't take you very long. This group takes a little longer. I'm going to work through one of them with you, show you how it works. What you are doing here is you are, actually let's just cross off that last row. I'll just have you do one of these. We'll do one together, then have you do one. You're being given one representation, and you have to write all the other representations. Like you're either given points or a map, and then you have to write it into all other forms. So let's do the middle one. On the middle one, we are given a map. Okay, so we're going to write out those ordered pairs and write out the table. This table, you're actually going to have to make a few more rows for how many numbers that are here. So we have an x of 1 that goes to -4. We got an x of 2 that goes to 0. An x of 3 that goes to 2. An x of 4 that goes to 6. An x of 5 that goes to 4. And then we have 2 arrows from the 6 here. So we have a point that is 6, 4. And then we got a point that is 6, 6. Okay, so before we even go any farther, is that going to be a function?
No.
Correct. It is not going to be because you got repeating 6s. Okay, once you have that, you can just write it over into ordered pairs. 1, -4. Ooh, that should be a 1. 1, -4, 2, 0, 3, 2, 4, 6, 5, 4, and then we got to make 2 more points. 6, 4, and 6, 6. So now we took the map, we made a table, we made ordered pairs, and last is just go graph those points. So you got the point 1, -4, 2, 0, 3, 2, 4, 6, which is just off the graph up at the top. 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. 6, 4, and then 6, 6. So you're just putting the points on the graph. Good with that? All right, so the rest that we haven't done, that's going to be homework. Even the word problems in the back. I want to see if y'all can figure those out, and then we'll go over and talk about them tomorrow. Okay, and that gives you about 12 minutes to get started on that. So see how far you can get through that. That first group, like I said, goes pretty quick because it's just yes